started today. We'll start them, we'll get halfway through, and then we'll finish tomorrow. So a geometric sequence is still a pattern, a list of numbers, but the thing about geometric is that you multiply to get from one term to the next. So for example, if you start with 3 and you multiply by 2 every time, you'd have 3, 6, 12, 24, 48, on and on and on. So that would be a geometric sequence, right? Not to be confused with arithmetic. That would be something like if I add 3 every time, 3, 6, 9, 12, 15, right? That would be arithmetic because you're adding 3 every time. But in the geometric, we are multiplying. So we have these sequences, and there's a formula, right? There's a sequence formula then and a series formula, right? Now we call the ratio, the number that you multiply by every time to get from term to the next, that's going to be called the common ratio. So it's similar to the common difference, but instead of the D, we're going to call that common ratio R. Okay, so in your formula, you're going to have an R. And here's the formula that we use. It is A sub n, so again, that's your sequence formula, equals A sub 1, the first term, times R to the n minus 1. Does that look like anything we've done in the idea of multiplying over and over again? What does it seem similar to? Not next, nothing. Exponentials. These follow an exponential pattern. So just like last unit, it's similar to an exponentials, and that means we might have a logarithm in here. X, 2. But it's a similar exponential pattern. Like we did last time, I'm going to skip this example for here because we're going to get a bunch in just a minute. But let's talk about series. Right? So we have sequences, which is just a list of numbers. When I have a series, that's again the sum, or adding up all of the numbers in the pattern. So for example, that'd be taking 3 plus 6 plus 12 plus 24 and adding all of those up. A non-example would be listing out terms or not adding up a term, but we'll just give you an example. So you add up the terms of a geometric sequence. Now there are actually 2 formulas down here. They're equivalent to each other. So basically, that means they're the same. The formula on the left says S sub n equals A sub 1 minus A sub 1 R to the n. That's the numerator. The only difference between those 2 formulas is what they did over here is they factored out the A sub 1. They just made it a little bit easier. We're going to be using the formula on the right because it's just a little bit simpler to use. Right? So again, you'll be given both of those formulas. You will need the first term, the common ratio, and the term number. Right? It's pretty simple for that. The formula works for every value of R, every common ratio, except for 1. So we have to think back to earlier this year. If I have a denominator of a fraction, what number can't be in general in a denominator? 0. This was on some of your tests last unit. So if I think about that, that means the denominator here, 1 minus R, can't be equal to 0. So what is R not allowed to be? 1. R cannot be 1. So the only time you can't find the sum is if your common ratio is 1. But that doesn't happen that often. That would be you're multiplying by 1 over and over, which would make your sequence something like 4. Oh, you can't really say it there, but like 4, 4, 4, 4, on and on. That would be 1. Okay, geometric series can also be written using something called sigma notation. We're going to talk about sigma notation after Thanksgiving, which is so close. It's a week from today. Thanksgiving, and then Christmas will be here, the New Year's, and then it'll be cold and dark forever. All right, flip the paper over. Let's talk about sequences. All right, so we have formulas again. We will be given all these formulas, but let's write them down so they sear into our head. The formula for a sequence is A sub n equals the first term, A sub 1, times your common ratio R to the n minus 1 power. Okay, that's where we're starting today. I'm not going to talk about the series formula because we're not going to get to it today, so I just want to stay right here. Okay, we'll do series tomorrow. So it says you formula to find a rule for finding the nth term of this sequence. So we're writing an equation. We've done that. You did that on your quiz today for arithmetic. Then we're going to find what the nth term is. So if I'm using this formula and I'm just coming up with an equation for the sequence, I'm going to write a sub n equals. Right? We want a formula a sub n equals something. Well, the formula says take the first term. What's the first term of the sequence? 3. So I have 3 times. Well, yeah, what are you multiplying by? -2. Right? 3 times -2 is -6. -6 times -2 is +12. So you're going to put -2 in your parentheses. And then your formula has n minus 1 as the exponent. So that's what you would call your nth term formula. It's just a formula for the sequence. Well, what term do they want us to find here? They want us to find the 8th. So where does 8 go in that formula? For n, so you're finding a sub 8. You are finding the 8th term. So you'll do 3 times -2 to the 8 minus 1. And you should have your calculator out so you can type that directly in. Make sure you put parentheses around your negative, and you can put either 7 in the exponent, or you can actually type in 8 minus 1. Okay? But make sure that you get the same value that I got. -384? Yes? Okay. Alright. Not too hard, correct? Not yet? Alright. That was easier than arithmetic so far. Let's do number 2. We have a sequence 2, 6, 18, 54, and we want to find the 18th term of this pattern. Okay, so again, we're using the a sub n formula because we're just finding a term of the sequence. So what should go in for n here? What term am I trying to find? 18. What's the first term? And what's your common ratio? What are you multiplying by? 3. Okay, so let's fill this in. A sub 18 equals 2 times 3 to the 17th power, 18 minus 1. That's as easy as this gets. It's not too hard. Let's see. Is it a long number? Yeah. All right. 258, 280, 326. Did you guys all get that? Guys, she has to leave, but we're still going to go. We have one more. Just one. Yeah. Are we good so far? All right. Let's do the third one. We are told that the first term of a sequence, a sub 1, is 4. The fifth term, a sub 5, is 9,604, and we want to know what is r. Okay. So, I need to know a couple of things. I need to know n for my rule. Do I know what n is? I do. Ooh, I know the fifth term. What's its n? 5. So I'm going to use n being 5 here. Okay? So let's put in what we know. For a sub n, I'm going to use the fifth term. I'm going to use 9,604. Okay? I know the fifth term equals my first term, 4. I don't know r. And what do we put for n? 4. N is 5. 5 minus 1, which the exponent is 4. Well, how should I solve this? How do I do that? Divide by 4. Okay, what's 9,640 divided by 4? What is it? 2,400. I think it's 1. No, it's 10. I wrote the numbers back. Yeah, we're good. Equals r to the 4th. Well, how do I take the... What do I do to get r? Take the 4th root. Do you guys know how to do a 4th root in your calculator? All right, I'm going to show you. Pay attention. You're going to hit the number 4. Then you're going to go to math. Under math, you're going to choose option 5. That's for any root that's bigger than 3. So you're going to choose option 5 because when you do, that little 4 becomes a root. Yeah? So now I have 2, 4, 10. Ooh, it's 2401.
Yes. Yeah.
See, you guys told me that it was 2410. I just took your word for it. 2,401, which is 7. So your constant multiplier here is 7. All right. So I want you to do a little bit for homework here. I want you to try. No. All right. So sorry about that. We wrote this down. It should be 2401, which is what we took the fourth root of, and the fourth root of that is 7. So 7 is the common ratio that you were looking for. All right, so that's what we have for geometric sequences. Let's go back up to the top of your paper real quick, and let's fill in the formula for geometric series. All right, so the formula we're going to use, I'm going to write it underneath, is S sub n. Remember, that's the series or the sum formula. The formula is you take the first term, a sub 1, times in parentheses 1 minus the common ratio to the n power all over 1 minus the common ratio. That is your series formula. So make sure that you have that written down. Hit pause if you need to. And then let's start the bottom part of our notes here. Okay? So let's talk about some geometric series. So what it says is here, if the first term is 1, so let's write down what we know as we know it. The first term of a series is 1. R is 2.5, that's your common ratio, so every term is being multiplied by 2.5. We want to find the sum, so it means we're using the series formula, of the first 13 terms. The 13 is your value of n. So when I put this into the formula, I'm trying to find the sum of 13 terms. Now it turns out I actually know all the information that I need. The formula, I start with a sub 1, which is 1 here. So I'm going to put a 1, remember this is a fraction, times some stuff in parentheses. Inside my parentheses is 1 minus. Now I take the common ratio, which is 2.5, and I'm going to raise that to the n power. Here that power is 13. Now the denominator of that fraction is 1 minus the common ratio. Now it looks kind of ugly, but when you type that into your calculator, the calculator will do all of the work for you. So we're going to take our calculator, and if you have the capability, which most of you do, I would set this up so you can type in a fraction just like this. You want to type in exactly what you have written on your paper. 1 parentheses, 1 minus 2.5 to the 13th. You want to make sure that the 13 is on the 2.5 and that you close the parenthesis outside. The denominator is just 1 minus 2.5. When you hit enter, it gives you this really yucky number, but that is the sum, 99,340.40796. That is the value of your sum, and that is your answer. So 99,340.40796. That would be the sum of your series. All right, let's look at number 2. It says, given this geometric series, 2 plus 6 plus 18 plus 54, find the sum, so again, we're using the series formula, of the first 15 terms. Let's write down what we know. We know the first term is 2. We know the common ratio here. I have to do 2 times 3 to get to 6. So the common ratio is 3. And the value of n that we're looking for is the 15th term, the sum of the 15 terms. So again, it looks like I have everything that I need to put into my sum formula. We're finding the sum of 15 terms. And to do that, we're going to take the first term, 2. And in parentheses, we're going to do 1 minus our common ratio to the 15th power. That's our n. All over 1 minus the common ratio. Once you have that written down, again, you're just going to put that into your calculator exactly as it's shown. So again, start with your fraction, and then start with what you have. Your first term times 1 minus 3 to the 15th power. Make sure your parentheses come down so that it's outside the entire quantity, and that your denominator is 1 minus the common ratio. When you hit enter, that should be your sum. This one's a whole number. So I have 1, 4, 3, 4, 8, 9, 0, 6. So let's see, 14,348,906. Okay, so if I added up 2, 6, 18, 54, on and on for 15 terms, it'd be in the 14 millions. All right, we are almost done here. Let's look at number 3. It says, find S sub 8 for a geometric series whose first term, that's a sub 1, is 40. The common ratio is negative 1.5. And over here, if I'm finding S sub 8, that means N is 8. So I want to find the sum. So I really have all the information I need. I just need to be careful when I type this in and write it down this time. All right, so I take the first term of 40. Now in my parentheses this time, actually I'm going to make that a little bit longer. In my parentheses this time, I have to do 1 minus. Now I want you to be careful. Because my common ratio is negative, I'm going to put the negative 1.5 in parentheses and then raise it to the 8th power. Close your numerator parentheses. Then in the denominator, I have 1 minus negative 1.5. So make sure if your common ratio is negative that you put it in parentheses when you write it down so that when you type it into your calculator, you do so correctly. Okay. So make your fraction. You're going to start with 40. Now just be really careful here. 1 minus. Put your common ratio of negative 1.5 in parentheses to the 8th power. Bring your caret down to close the numerator. Then in the denominator, you're going to do 1 minus negative 1.5. When you hit enter, that should be the answer that you get, negative 394.0625. All right, and there you go. Now it says find S sub 9 for the same geometric series. So let's do that. S sub 9 is actually, the nice thing about geometric is that the formula, you don't need a lot of information. If I'm finding S sub 9, the only thing that's going to be different in what I write down here is what N is. Because this time N is going to be 9. So I'm going to do 40 times, same thing, 1 minus negative 1.5 to the 9th power this time, over 1 minus negative 1.5. So this time, I'm going to go back to my calculator, and I'm going to save myself a little work. I'm just going to copy down what I typed, because the only thing that needs to change is my exponent. That just needs to turn to a 9. You can retype it in if you want to. When I hit enter, this is the sum this time, 631. So it says that my sum is 631.09375. Well, the question is, notice anything strange. Our sum was just negative 394, but the next term, my sum was all the way up to the positive 600s. The reason for that is because our common ratio is negative up here, the terms alternate. So you go from, like we started with positive 40, the next term would be negative 60, and then positive 90, so on and so on. And because those signs are alternating, it looks like the 9th term is just so big that it added a really large value to that negative sum. All right, one more problem here to do. A geometric series has a first term, a sub 1 of 2, a constant multiplier, a constant ratio of 4, and a sum of 174,762. How many terms are in the series? So that means we don't know n. So I know S sub n, but I don't know what the term number is. Well, since they give me S sub n, let's use the series formula. Okay? So let's fill in what we know. I know S sub n is 174,762. I know A sub 1 is 2. I'm going to have 1 minus my common ratio of 4 to the n power, I don't know what n is, all over 1 minus 4. All right, so let's start. We need to find n. So it looks like I have a good place to start here. Let's simplify that expression. So I'm going to rewrite that as 174,762 equals 2 times 1 minus 4 to the n over negative 3, 1 minus 4. Now to solve that, what I think I would do is multiply by negative 3 on both sides. That'll get rid of my denominator. All right, so let's take 174,762 times negative 3. So that's what I'm going to have on both sides here. So I will have, make this a little bit lower. I'm going to have negative 524,286 equals 2 times 1 minus 4 to the n. Now the next thing I would do, I'm not going to distribute. Don't distribute the 2. The next thing you want to do actually is to divide everything by 2. Because then when I divide that number by 2, I get negative 262,143. So I have now negative 262,143, and that equals 1 minus 4 to the n. Okay, so I'm getting closer. This should be starting to look kind of like something we did last unit with exponentials and logs. So I'm now going to subtract 1 from both sides. So when I subtract 1, I get negative 262,144 equals negative 4 to the n. Okay. We're getting there. It's just a lot of steps. The next thing I need to do before I can get rid of the n in the exponent is, remember, there's like a negative 1 out in front here, and I need to divide it away. You cannot take the log, which is what we're going to do, until you divide by negative 1. When you divide by negative 1, you get a positive 262,144 equals positive 4 to the n. Now this is helpful because remember when we did the last unit, we said if there is a variable in the exponent, the only way to get that variable out of there is to throw a log at both sides. So you're going to take the log of both of these sides here. And when you take the log of this right-hand side, that n comes down in front. Because now all you have to do is divide by log of 4 to get your value of n. So we're going to type that into our calculator. Log of 262,144 divided by log of 4. I get n equals 9. So that tells me that the number of terms I added up originally to get the sum of 174,000 is 9 terms. So you start at 2, you multiply by 4, keep doing that 9 times until you get all this work done. Okay? So you have a little bit of practice here. You have 1, 2, 3, you have 8 problems. All the answers are on the back. Go ahead and give those a shot. We will have time in class to go over them. Check the key that is posted on Canvas so that you can make sure that you're doing things correctly.